All right, welcome to part 2 of transformation of trig graph notes, where we're going to move graphs up, down, left, and right, and vertically stretch or shrink them. And we might even do a reflection. All right, so here's what's going on. Hopefully you were able to explore in your Desmos activity that when we talk about parameters, those are like slots, things in the equation that have a specific role. The a value, the factor in front of the trig graph, it's a multiplier. This is going to affect your y values. It's going to cause a change in your amplitude if it's something other than 1. So that's going to be your vertical stretch or your vertical shrink. And it also has to do with the reflection. If you have so this is, I guess, how I write it. If you have, I wanted to erase. If you have an a value, then your parent graph is regular. But if you have a negative a value, that causes a reflection over the x-axis. Some kids ask, well, what about a reflection over the y-axis? Well, that would be something that happens if your b value is negative, and I'm going to just be upfront. We're not going to explore a lot of those graphs in this particular lesson. All right, next. I'm going to talk about this in a certain order and do this color coding. The K has to do with a vertical displacement. Your K moves the graph up and down as well. So that's affecting a Y value. I'm explaining it this way because if we go to a table, these are the values that will directly affect a Y value in your table. So your vertical displacement, a positive K value goes up, a negative K will move your graph down. Now, it is the parameters in the interior, the argument of your sign. And notice how that b value is factored out. If you have something that's in bx minus bh form, this is not going to be your phase shift or your horizontal displacement. This x has to be a 1x inside that factor in order for you to make a decision on your phase shift. So the period is affected by the b. So for sine, cosine, cosecant, and secant, if you take 2 pi and you divide it up by b parts, that's going to give you your period. However, if you're dealing with tangent or cotangent, it's going to be pi over b because they're pi periodic. And then your phase shift, if you have a plus h, it's actually an opposite. So anything on the inside is going to affect an x coordinate in an opposite way. A plus h actually moves left, and a minus h actually moves right. So let's do some examples. All right, for sine x. I want you all to understand that I am aware that some of you can say, oh, it's just an amplitude change. And I am just going to go up, down, in here and give me a graph. Awesome. I also know where we're headed into much more complicated graphs, so please bear with me while I do an easy problem, quote unquote, the long way, so that when they get more difficult, you know what's going on. So again, to be clear, this is not wrong. I will tell you I wouldn't give you full credit. Remember I talked about those 4 pieces of information? I need information that you know that this is at pi over 2. I need the pi marked. I need the 3 pi over 2 marked, and I need that 2 pi marked. This would be full credit. So just to be clear, you are going to have to show me all of your x and your y values. All right, so let me start another way, and that's by using a table. All right. So I have, oops, I don't know what happened there. Let's get rid of all that. So I have x, and let's talk about sine x, the parent graph. So I have 0, pi over 2, pi, 3 pi over 2, 2 pi. The sine curve starts at 0, goes up to 1, back to 0, down to negative 1, and then to 0. All right, we've got this 4. This 4 is affecting the amplitude. Since it's on the outside of the sine, it's not in the argument, that's going to affect a y. So when I want to graph 4 sine x, that means I'm going to have to multiply all of these y values by 4. Was the period affected? No. The period is still 2 pi. Is there a phase shift? No. Was there a vertical displacement? No. Was there reflection? No. Because the only thing that changed was that I have an amplitude of 4, which is going to cause all the y values to increase by a factor of 4. So now we plot. And I know that I have pi over 2, I have pi, I have 3 pi over 2, 2 pi. That's clearly marked. This is showing me evidence that you know exactly where each of those points have to go. And I only need one period. You might have a teacher that will require more than one, but this gives me the information I need to know. All right, let's do 1 minus sine x. Oftentimes I have kids that say, I don't like that, that's awkward. So I'm going to write it as negative sine x plus 1. All right, let's start again from our t-chart, right? Let's think about our parent graph. Our parent graph is the sine of x. So I start out with 0, broken record, pi over 2 pi, 3 pi over 2, 2 pi. The sine of x starts at 0, goes up to 1, back to 0, down to negative 1 to 0. But this time we have 2 parameters causing changes. But those parameters, again, are both on the outside. So these are both affecting your y coordinate. Now, there is a certain order you have to follow, and I want you to think about your orders of operations. You have to do all multipliers before you do any add-ins. So this negative has to be dealt with first because that is a multiplier. So I am going to, when I want a negative sine x, this is going to still be 0, this is still going to be 0, that's still going to be 0, but that's going to change to a negative 1, and negative 1 changes to a positive. And then I have to add the 1 separately, so now I'm going to add 1 to each of those values. And now we can graph. So again, I'm going to need what? 2, 1, and I'm at 0, I'm at pi over 2, I'm at pi, 3 pi over 2, and I'm at 2 pi. So I'm at 0, 1, I'm at pi over 2, 0, I'm at pi 2, I'm at 3 pi over, I'm at pi 1, my bad, pi 1. All right, I am at 3 pi over 2, 2, and then I am back down to 1. And there's my graph. Now, if you could go straight to that without a table, totally fine. Not a problem. But I just want to give you an option because when we start putting in even more parameters, I'm just letting you know that a lot of kids find that this is kind of they find comfort in a concrete way to graph instead of having to do so much in their head. You still have an amplitude of 1. To be clear, an amplitude is always a distance. So you're always going to take the absolute value of whatever number is your factor. Because what that negative does is it does cause a reflection over the x-axis. Your period is still 2 pi, there was no phase shift, and your vertical displacement was up 1 unit. All right, here we go. And I know these are all with the sine curves. Please know that if you're doing any of the other curves, it is the exact same process. All it is just a different t-chart. All right, here we go. So we're going to do the sine of x plus pi over 3 plus 2. So we're going to start out with our parent graph, right? So this is going to be the same parent graph if it was cosine. It's going to be the same parent graph if it was cosecant or secant. It's the cosine and the cotangent and the tangent that would look a little different. So we still start at 0, up to 1, down to 0, negative 1, and 0. All right. So notice this time I have an amplitude of 1. So I'm not going to have to multiply my y values by anything. Plus 2 is also on the outside. So all I have to do is add 2 to each of those values. But here's what's new in this problem. We have an x plus pi over 3. So since there is no b, your b is 1, my period is still going to be 2 pi. But I do have a phase shift. And anything that occurs that happens to an x value always goes in an opposite fashion. So anything on the inside is always opposite. So if I have a pi over 3 and I'm adding it, what you're actually going to do is subtract a pi over 3 from each of these x values. You are expected to be able to do this without a calculator, so this is going to be some common denominator work. That is the hardest part. This is after this, you plot and you're done. All right. So from 0 take away pi over 3 is negative pi over 3. Well, if I have to take pi over 2 minus pi over 3, I need to get them in both in sixes. So this is 3 pi over 6 minus 2 pi over 6. So this would translate to pi over 6. It's pretty easy to subtract with pi because pi in terms of thirds is 3 pi over 3. So this is going to translate to 2 pi over 3. 3 pi over 2 in sixth becomes 9 pi over 6. So, right, because we multiply both sides by 3. And I'm so sorry, I've got a small mistake here. We need to be in thirds. So this is going to be minus 2 pi over 6, correct? Pi over 3, multiply by 2 over 2, there we go. So this would give me a 7 pi over 6 after that's translated. And then if I start originally at 2 pi and I want to subtract pi over 3, this is going to be and we want this in thirds, right? So 3 over 3. So I'm going to have 6 pi over 3. So this is going to be at 5 pi over 3. And this is why some kids will take the period, divide by 5, figure out where you start, figure out what your end. There is more ways to figure this out. I just think that this is the most direct way because somehow or another I need, for full credit, I need to know those x values. You can't just write any old graph on here, and just, do something like that and get full credit. I need detail. All right, so I have negative pi over 3, and we're going to be at 2. At pi over 6, we're going to be at 3. At 2 pi over 3, we're going to be back to 2. At 7 pi over 6, we're going to be down to 1. And at 5 pi over 3, we are back to 2. So we did have a phase shift that went left pi over 3. You had a vertical displacement that was up 2, and there was no reflection in the graph. So I know that those were only 3 examples, but hopefully that kind of gets you started. You can do the transformation of trig graph worksheet. Again, we're building up to a skill set where we do much more complicated graphs. And in the next lesson, we will do examples where we have everything, and we will do some non-sine graphs as well. Enjoy.